Hello, this is James Weeden for Dr. Zebrajati's class, and today I'll be going through problem 2.5. So to start, the first thing we want to see is that we can use our propagation constant to solve this problem, since our propagation constant consists of both alpha and beta. So using this equation here, we can plug in all of our values. It's important to note here that our omega, let me get a different color. Our omega here is simply 2 pi times our frequency, so we can just plug that in. After plugging in all these values, we can simplify, and after that, from here to here, we can convert to phasors, and once you're in phasors, you can simply multiply your magnitudes and add your phases to push everything into one clean number here. Just as a quick review to how to convert to phasor form from this kind of Cartesian form, you can take the square root of both the real and imaginary components squared, and you can take the inverse tangent of the imaginary over the real component to get a phase angle. For here, since we only have an imaginary component, our phase angle is simply 90 degrees. So after this, we can take the square roots of the value, and so we simply take the square root of our magnitude, but divide by 2 for our phase angle. So then converting back from our phasor form into our Cartesian, we simply take the cosine of the cosine and sine of our phase angle times the magnitude and split it up like this. So then we get our propagation constant as this value here. And since we know that alpha is our real component, we can simply say it's 0.016 nepers per meter, and our beta as the imaginary component is 34 radians per meter. Going down here, we know that our phase velocity is simply our frequency divided by our beta term, so that's pretty straightforward. And then after that, to solve for our characteristic impedance, we can actually use the same two parts that we used for the propagation constant, so not much more computation there. Since we already have it in phasor form, we can simply divide this time. Remember, you just subtract your bottom angle from the top one for division, and we get our form as this. We want to convert to our exponential form, so our final answer is 31 e to the negative j 0.025 degrees. And remember, our units are in ohms since it's an impedance. Thank you.